So we had around 64 electrodes. We got a data set in which there were 64 electrodes which were placed on the head of patients like this. And your brain region is divided into 5 lobes. I repeat again, your brain is divided in 5 parts or 5 lobes. As you can see over here, this is nothing but your frontal lobe. If you zoom it properly, you can see the frontal lobe has been designated by this red color dotted line. Somewhere over here it is going, and then from here again this is your frontal lobe, if you can see carefully. So this is your frontal lobe, and then we have got the temporal lobe. Over here is the temporal lobe. If you see carefully, this is the temporal lobe. So similarly, you have frontal lobe, you have temporal lobe, then you have again one temporal lobe is over here. It is termed as left temporal lobe and right temporal lobe. Okay. Then we have parietal lobe over here, which is given by yellow color dotted line. So this yellow color dotted line, if I have the color sequence, that yellow color dotted line, okay, let me get the yellow color. Okay, so this yellow color dotted line, it goes somewhere from here. It's even difficult for me to see. The photo is not clear. Then to somewhere over here it goes. So this is complete your parietal lobe. Okay. So from here till this part, again this is your parietal lobe. Okay. So this parietal lobe is designated by the letter P. That you must just understand. It is designated by the letter P. So, and next we have occipital lobe, and then we have central lobe. So here central lobe is not being shown. So whatever letter C is there, if you can see carefully over here, whatever letter C is there, see over here, here you can see a letter C, then here you can see a letter FC3, then FC1, then FCZ and F2. So all these are the part of central lobe. So since I'm not from the biomedical area, biology area, so it becomes difficult for me even to explain. So these are the central lobe electrodes where C is mentioned, whether it is CP4 or CP6, but C is mentioned, so C is there. So this is nothing but your central lobe. So in this way there are 5 lobes. 5 lobes. So I will say we have frontal lobe. In frontal lobe everything will be designated by letter F. Then we have frontal lobe, we have central lobe designated by C. Then we have parietal lobe, Parietal, parietal lobe designated by letter P. Then we have occipital lobe, occipital lobe designated by O. And then we have temporal lobe, left temporal and right temporal. So there are temporal lobe designated by T. Temporal lobe designated by T. So 1, 2, 3, 4 and 5. The image is not clear. On internet you will be finding very nice images. From there you will understand. Okay. So in this project what we are trying to find out is which lobe, whether it is frontal lobe or parietal lobe or combination of frontal and parietal lobe, responsible for major depression disorder. So what we have done till now is, one of the student, he generated around, I think 7 features, signal features. You will understand it because we have done it before. So he has generated 7 features for each electrode. So let me just go over there. This was the data sheet provided by him. Okay. So this was the data sheet provided by him. So if you see, here it is CPZ, parietal lobe, CPZ. So where the electrode CPZ is there, let me come over there. See over here, CPZ. CPZ, this electrode where I'm circling, see this electrode. So for this electrode, one signal feature was there, and for this electrode, for one signal given by this electrode, he has collected 7 features. He has obtained 7 features. So this is the first feature, which is CPZ complexity, as you can see over here. See over here, CPZ complexity. So this is the first feature, CPZ complexity. CPZ peak to peak, CPZ, what is it? It is where it went, CPZ. Okay, here I was circling. Oh, I was actually here. I was not in the starting. So this is CPZ RMS, then CPZ CADS FD, then CPZ RMS is there. Let me just zoom it. Then CPZ kurtosis. No, then it is CP2. Here it is CPZ mobility, CPZ activity, CPZ skewness, and CPZ kurtosis, CPZ RMS, like that. So it is starting from here. So these many features were generated by him for one particular electrode. For one electrode, 7 features. So there are 64 electrodes. So 64 into 7, that many inputs were available for finding whether it is uh, a person is having MDD or not. Okay, so this was decided earlier that we will take the help of all the 64 electrodes and we will try to find out whether the person is having MDD or not by machine learning. But later on, when I went through the research article, I found out that there are certain brain regions which may contribute for MDD. There are certain brain regions which may not contribute to MDD. Okay, so what you have to do is you have to make different feature set inputs. You have to make different inputs. For example, I'll tell you, let us first consider only frontal lobe. So in frontal lobe, how many electrodes are there? If you see carefully, so this is the say this is first electrode, second, third, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then again this 15, 16, 17, 18, 19, 20, 21. 21, this is 22. Even this one they have considered 23. So there are 23 electrodes in frontal lobe. So what we will do is, in our first modeling study, we will consider only this 23 electrodes of frontal lobe. So 23 electrodes of frontal lobe we will take, and for each electrode we will find 7 features. Okay, so what is the calculation that you get over here is, if you see carefully, so in frontal lobe you have 23 electrodes, and each one electrode gives 7 features. Okay, so total input sheet will be having how much? 23 into 7. This much will be the inputs, and one output will be there. Okay, so in this study what I have done is, I have not taken frontal lobe, but I have taken occipital lobe I have taken. So this is the occipital lobe over here. So in occipital lobe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 electrodes are there. So in total 12 into 7 features, so this many inputs are there. Okay, so from this sheet which was made by one of our student, this data sheet which was made by one of our student, for complete all the electrodes, what I did, I only took the inputs of occipital lobe, and after that I have just taken those columns and copy pasted in another Excel sheet. Okay, and then I got which one, just a second. So I had saved over here. Okay, then I got this occipital Excel sheet or .csv file, in which only those electrodes are there which are of occipital lobe. So the number of feature set got reduced. If you see carefully, the number of feature set got reduced. So these are all the features or inputs of occipital lobe, and this is the output MDD. Okay, and now I have taken this sheet as my input or my data sheet. I have taken this occipital sheet only for occipital lobe as my input in this Google Colab. Okay, then what I have done is, these are the libraries, and see, I am using the code of ANN and some of the algorithm, and this was already performed by one of the student, and I have edited over here. Um, we have used some algorithms. I'll just tell you, and then we will proceed further. So we have used some algorithms. We have used ANN, we have used random forest, then DT, we have used naive Bayes, and then we have used SVM. Okay, so these 4 5 algorithms we have used. Now see, after uploading, you can see the electrodes and features of occipital lobe is there. O represents to occipital lobe. So PO6 means this electrode was common in parietal as well as in occipital lobe. Okay, only O represents the electrode was there only in occipital lobe. That you must understand. ठीक है, जैसे कि ये वाले जो electrodes हैं, this O1, RMS O1, kurtosis, they are properly in occipital lobe, and this CB1, CB2, they were also there in occipital lobe, although it is not starting with this thing. See, CB1 over here, CB1 and CB2. So here it is CB1 and here it is CB2. I will send the photo in the group, then you will understand it properly. Okay, then we have seen the df dot head. So df dot head, it will give me only 5 rows. Then divided it into your x input and your output that I have done. As you can see over here, I've divided it into input x and divided it into output. So in order to get x, I have dropped this MDD column. We have done it many times. For y, we have put all the MDD values in y. Then we have done train, test, and split. Here I have taken test size as 20%. Okay, some random state I have taken. Then we have done scaling procedure. Okay, then we have done scaling procedure. It was already explained why scaling is done. Scaling is done because your input has got different numbers. As you can see over here, this column it is having 0.9, 2.30, 338, something is there, and this column is minus 0.14. So after normalizing, what will happen? Their ranges gets fixed. Okay, so I will not explain in detail. So it is normalized. Even if you don't normalize, it is okay, but most of the time it gives you a wrong answer, if incorrect answer, less accurate answer. So this how we have normalized the things. Okay, we have conducted numerous lectures in which we had normalized everything. Then for first algorithm, which is artificial neural network, which is a part of deep learning, we have imported some of their packages, some of their class. And here, currently, what kind of ANN architecture we are using, you see carefully what we have done over here is how many inputs we are having. I'll go upwards and see how many inputs we are having. So in order to know the inputs, did I run this? Yes. So see x dot shape. I have given the command of x dot shape over here. So it is 119, 96. So in row 119 rows are there and 96 columns are there. Input columns are 96 because x dot shape I have used. So 96 is there. So I have put 96 over here. See what is happening. Let me explain the architecture of ANN again. So input is 96. So there are 96 neurons. So 1, 2, 3, so on, so on, so on. 96 neurons are there. So this is first neuron, this is second neuron, third, and this is 96 neurons. What does this neurons illustrate? They illustrate the input features. What kind of input features you see over here in occipital lobe? So I will just be writing the first input feature. So CB1 RMS, CB1 RMS. So CB1 electrode का root mean square value, CB1 electrode का root mean square value is there. ठीक है. So my first feature I can write it as CB1 electrode का RMS. So CB1 का RMS feature is there. Okay. Similarly, CB1 का kurtosis will be there, and so on, so on, so on. We have another last electrode का some feature. ठीक है. तो ऐसे this many inputs are there. So in the first line, input dimension is given as 96. Then in the first hidden layer, there are 10 neurons in the first hidden layer. So this is the first hidden layer, 1, 2, 3, and so on. There will be 10 neurons, not electrons, sorry, 10 neurons. So in the first code, you have how many neurons are there in first layer, which is your input layer, and how many neurons are there in your second layer or hidden layer, first hidden layer. Second layer is your first hidden layer. Okay, so here it is 10 neuron. Then next code that you write, you give only information about the next hidden layer. So in next hidden layer also 10 neurons I have put. So again here 10 neurons will be there. 10 neurons. Okay. So this is my first input layer. This is my first hidden layer. This is my second hidden layer. And then I am having one output layer. So there is only one output in output layer. So this is my output layer. Okay, output layer. So output here it is MDD, whether the patient is having MDD or he's not having. So this is how you get the connections from here to here, here to here, here to here, from here to here, like this one. And on every line you will be having one weight. So weight is equal to, for example, say 0.96, and on every circle you will be having one bias as well. One bias is also there. Okay, so this is how the connections are made. Every time, in every iteration, it will go back by backward propagation and change these values of it. These has been explained already. Okay, so I will not repeat it. So let us just run this part. I'm deleting this part. I'm deleting. Okay, so let me just run this part now. Let me form the architecture. Shift run. It is forming the architecture, and then we are compiling the model. We are using accuracy as the matrix and loss function as binary cross entropy. So let me just run, and now I want 500 epoch, means 500 iteration with validation split of 0.1. Okay, let me just run. So now you can see at every iteration, how the accuracy changes for every iteration. Okay, people who did not attend the lecture for ANN, we are going to start with CNN, which is almost similar. There you can understand it really well with the image data. Okay. See, this is running and your accuracy is improving. You can see this much, this part, your accuracy is improving. See this part here, 70, 60, something, something is there. And I have given 500 iteration. Since the RAM capacity and the other thing, it is not a GPU, it is going very slow. I have given 500 iteration. I would have given only 100 to demonstrate. So we shall just wait. See, in order to get a good fit, this accuracy and validation accuracy should be almost similar. If it is 82, 84, it should also be around 80 or something. So it is increasing. The problem with this project is the data is less. Only 119 patients were there. So getting a better accuracy is a very difficult challenge. It is a challenge. Okay. So we have got 83 accuracy and validation as 0.8. So what we can do is, in order to further see whether the accuracy can be uh, improved, what we can do is we can go ahead and we can change these neurons in hidden layer. Instead of 10, I can make it 100. Okay. So I will run this again. Again, I need to run. Again, I need to do the history. Oh, I should have. Now the accuracy may change. See, it has started with 60 now. It has started with 60. Again, it will go till 500. Actually, I should have given only 100 iterations. And this part is showing loss. Loss means error. I had already explained what is accuracy, what is validation accuracy, what is the difference between them. After generating an accuracy, it will put around 10% of the data again to check, to test. You can say you can test again with the 10% data. So that is validation accuracy. Testing is going on simultaneously. Testing is going on simultaneously. Like your teacher is teaching a lesson inside the class. First time when you write the answer, you see the answer and you write. And on the same day, the teacher is also taking test. So she taught you 10 numerical and she's taking test by only one numerical. Okay, so teaching and testing is going on simultaneously. Okay, so this is how you can change the architecture of artificial neural network. You can add some more hidden layer over here and you can run it again. So I'm adding one more hidden layer. In that you can change the number of neurons. So no one will tell you how many neurons should be added, how many hidden layers should be added. Either we can go for hyperparameter optimization or you can change it manually. So I will just reduce the number of epoch just to show you. 50 I am making it. See, so it is starting with some 90 only. But your validation accuracy has reduced to 0.7. Both should be better. Okay. This is how you need to run. Moving forward, this is the graph which shows the history of your accuracy and your validation accuracy. Both the graphs should be almost coinciding. Okay. Like if it is 95.95, it should be 0.89 or 0.92 like that. But it is not coinciding. So you need to work on it. Now predicting the actual prediction of training and testing will be done over here. I will be providing you with the codes in your group. Okay. So your why predicted in testing and why predicted in training has been done. For training, it is a big this thing, and for testing, it is this one. And now actually training error, not sorry, training accuracy and testing accuracy you will find. So your testing accuracy is 0.6 and your training accuracy is 0.61, which is very much low. What you need to do is you just take this part 0.66 for testing and training, and after hyperparameter optimization, you go in this Word file and then you can go. So these many things we need to check. For ANN, it was what lobe was there? Occipital lobe. So sorry. So it was 0.66 and this was how much? I think it was 0.67 something or 0.65, 0.67. Okay, so this was for occipital lobe. But in ANN, you need to try various optimizers. Currently, it is ADAM optimizer. Then again, you need to try with what do we say? A different activation function, different learning rate. So many things are there to be optimized. Okay, now we are coming to hyperparameter optimization of decision tree. This we had already done, so I'm running it, and it will directly give you. See, training accuracy is 0.73, testing is 0.58, 0.73 and 0.58. So for it was decision tree. So 0.73 and 0.58. Again, here you can change the hyperparameter for higher accuracy. For example, over here, it was many more parameters are there in decision tree. we can put minimum sample leaf 10, 20, 30, 40, 50, 60, and so on. You can do it. So I'm just explaining you as a sample. Then we have random forest. In random forest, how many trees has he used? So it will take some time. An estimator, he has taken 300, 400, and 500. Hence, it is taking some time. You can just skip this part. Okay, it is taking some time. Okay, so similarly, we have support vector machine and we have k nearest neighbor. Okay, and I had also applied principal component analysis, but I will not be showing that thing in this lecture. Let us just everyone work together and let us just submit this paper in some good journal. So many work is pending. You can see frontal lobe, central, parietal, temporal, then their combination FCP, FCO, and many other, and then all. So this has been done with only 7 features. This has been done with only 7 features. What if we have more than 30, 40 features? If the accuracy is not going up, even by hyperparameter optimization, there is a problem with the features that we have obtained. Then we will have to go for higher value of feature or for principal component analysis. Okay, first we will do with this, then we will do with principal component analysis. So it is done. Is it done? Okay, so it is giving 64 and 66. So I will not run all. I will just send these codes in the group. Please complete.